Line reflections. A reflection is a flip. It is an opposite isometry. The image does not change size, but the lettering is reversed. Reflection on the x-axis. When you reflect a point across the x-axis, the x-coordinate remains the same, but the y-coordinate is transformed into its opposite.
So if there is a point like 2, 3, if you reflect it over the x-axis, it will become 2, -3.
Reflection in the y-axis. When you reflect a point across the y-axis, the y-coordinate remains the same, but the x-coordinate is transformed into its opposite.
So 2, 3 become -2, 3.
Reflection in y equals x. When you reflect a point across the line y equals x, the x-coordinate and the y-coordinate change places.
So if there's a point like 3, 1, you would count how many spaces it is from the line. So it's 1. So the new coordinate would be 1, 3.
Good. Reflection in y equals -x. When you reflect a point across the line y equals -x, the x-coordinate and the y-coordinate change places and are negated. The signs are changed.
So if there is a point like 2, 2, count, it is 2 places away from the line. So the new coordinate would be -2, 2.
Point reflections. A point reflection exists when a figure is built around a single point called the center of the figure. It is direct isometry.
So if there's a point like 2, 2, it becomes -2, -2.
Now we've got one.
Yeah.
Are you ready?
Mm-hmm.
Rotations. A rotation turns a figure through an angle about a fixed point called the center. A positive angle of rotation turns the figure counterclockwise, and a negative angle of rotation turns the figure in a clockwise direction. It is a direct isometry.
Okay. So if the point is 2, 2, you can turn the paper 90 degrees, and -2, 2 would be your new coordinates. And if you turned it 180 degrees, you do the same thing. 270 and 360. Oh, I need to draw a figure.
Dilations. A dilation is a transformation that produces an image that is the same slope as the original but is different size. Not an isometry forms similar figures.
So, if our dilation, if we were dilating it by 2, it would become 2, 2, 6, 2, and 4, 6. And that would be our new shape.
Translations. A translation slides an object a fixed distance in a given direction. The original object and its translation have the same shape and size, and they face in the same direction. It is a direct isometry.
So if it wanted us to translate 3, -4, if our point was 2, 2, we would go over 3 and down 4, and that would be the new point.
Glide reflection has opposite isometry, distance, angle measure, parallelism, collinearity,
Collinearity.
midpoint are all properties preserved, and it's reverse orientation.
So to do a glide reflection, we first are going to flip it over the x-axis. So this new point. And then we are going to flip it over the y-axis.
So right here.
And it needs to stay parallel to the first shape you flipped. So this is our new shape.
And for line reflection, it has opposite isometry. Point reflection, translations, and rotations have direct isometry, and dilations have no isometry. And figures are similar though. And for line, point, translations, rotations, the properties preserved are distance, angle measure, parallelism, collinearity, midpoint. And for dilations, the properties preserved are angle measure, parallelism, collinearity, and midpoint. But the lengths aren't the same for dilations. And all the other ones are same orientation except for line reflection.